Good morning and good afternoon, everyone. Welcome to the webinar. I'm really excited to get started and share some of our new information with you during the session today. Just a reminder, as Monica said, we do have a board giveaway promotion that we're offering. So if you stay through to the end of this riveting presentation, you'll be entered into the opportunity to win a development kit. And we will get back to the winners towards the end of next week. Okay, so let's get started. There we go. So let's get started with just a few topics, the agenda that I want to cover today. So first of all, I want to give just a short background to the i.MX application processor family. For those of you who are new to i.MX. Then I'm going to talk about the 8M Nano specifically and what we're doing there in terms of technical capabilities that it brings to you. Then we'll talk about some design challenges that we address directly with the product that we have and the enablement that we built around it. Then we'll give a couple of real-world application examples, and then we'll wrap up with an overview of our partner ecosystem and some of the go-to-market information that we have that you can get started with today. So with that in mind, let's get started. i.MX, we've been successfully releasing this product to the market for about 15 years now. We started in 2005 with the introduction of our very first product, the i.MX. And since then, we've had a significant impact globally on many different industries with the products that we're building from Freescale and then NXP. We've released many products, as you can see on the right-hand side here, crossing multiple industries. So we have a strong pedigree in automotive, consumer and industrial. We've seen incredible growth over these years as customers like yourselves have adopted our products and put them into applications that then ship out to our end customers. We have continued to release every year new products built on new architectures and new capabilities. And we've shipped over 600 million i.MX processors to date. So really extending a great portfolio out to our customers. What we're building with i.MX is what we call secure connections for the smarter world. And this is what NXP as an entire company is bringing to you. We consider we're bringing intelligence to every product that we build. And that impacts you by being able to assist you with deploying intelligence in your products, which has great benefits in terms of saving power, creating more efficiencies, cost sensitivity in your applications as well. Everything connected, so we are bringing connection to our products. We recently announced that we have successfully closed all regulatory approvals to acquire Marvell's Wi-Fi and Bluetooth connectivity assets. And that's expected to close in the first half of December. So we're really excited to, as we move into the next decade, to bring Marvell's disruptive, in particular disruptive Wi-Fi 6 portfolio and all of its existing Wi-Fi and Bluetooth products to our i.MX processor family and across the entire portfolio of NXP. That will help us to create truly differentiated platforms for you, our customers. And security. So we're also, with our product portfolio, bringing advanced levels of security to our products. And that benefits you across the board. NXP is a leader in providing secure solutions, and we've been embedding security into i.MX since day one of product release. Why do customers consider i.MX? We have a strong reputation as being a trusted long-term supplier. We have longevity programs that are promoted on our public website, nxp.com. We have 10 and 15-year minimum longevity programs for our products. Every single i.MX processor that we release goes onto this longevity program. We understand that our customers can take several years to get their products into production, depending on the industry and the certifications required. So we want to ensure that when you are ready to go into production, that you have a continued commitment from NXP to ship product to you through the lifetime of your solution. We have products that cover extreme operating conditions, and what that means is being able to run a product for a minimum of 10 years continuous operation. We call that our industrial operating mode. We have application notes on nxp.com that describe these different operating modes and how you can extend the life of your product, not longevity of supply, but actual lifetime of your product running in its application. We do have extreme temperature for industrial, so we have -40 cold start, and we run up to 105 for hot operation for industrial 10-year operation. We have implemented low power consumption in our products across the board to enable fanless operation. We achieve that through selection of process node, design innovation that we have from our hardware and our systems engineering teams, dedicated hardware acceleration where you're putting a lot of performance onto a chip. For example, graphics and video, we put a lot of dedicated video accelerators and graphics accelerators to give performance and power efficiency, and software optimizations that go in and really seek out all the benefit of the hardware in terms of power efficiencies and make sure that we operate it from a software level as well. We innovate on small footprint design in terms of packaging to enable space-constrained applications. And then for some devices, we do have automotive options available that can provide up to 125 junction temperature operation. So i.MX is really seen as the go-to product for customers, whether they're building automotive, industrial, or consumer devices. We're also a trusted security partner. As I mentioned with i.MX, from the very inception back in the mid 2005, we have implemented some form of security, whether it's secure boot, crypto accelerators for digital content protection, secure JTAG and debug capabilities. We've implemented that from the start, and we just continue to optimize and harden those implementations. We have a consistent set of APIs that enable our customers to unlock the security capabilities of our products. And we also have an NXP security crisis management team that helps to evaluate any new threat that might be made apparent in the industry, and help our customers to implement the most robust security solutions they can, given the hardware capabilities that we have on our products. So really strong leadership in security from NXP and i.MX. And then since we've been in the industry for 15 plus years with i.MX, we, as expected, we have an incredibly strong community around i.MX in terms of our ecosystem and our support. We have hundreds of partners that we're actively working with today, and they cross all disciplines, from software enablement in terms of perhaps customizing a BSP, optimizing it and hardening it for production, working with Microsoft for Windows 10 IoT core enablement. We have Linux and we have Android enabled through NXP and through our partners, and other operating systems as well. We have an incredibly strong ecosystem of board partners providing embedded board solutions to you so that you can rapidly get your products into production. We have machine learning, AI partners, we have graphics partners, we have component partners such as memory, PMIC, connectivity, etc. So an incredibly strong ecosystem around i.MX that gives you confidence that when you start designing with i.MX and you need additional services from for your product development, that you'll have partners to go to get those implemented. Okay, so i.MX, I've been with the product line since it started, so I can speak to the incredible breadth and success that it's had in the marketplace today. So I'm really excited to continue to bring new products to you. And today we have the 8M Nano, which is our latest product from NXP in the application processor space. It's a quad-core applications processor for secure, intelligent, and cost-effective edge computing. So our i.MX 8M family really has, if you're familiar with the i.MX 6 series of processors, which launched back in 2012, and we've had many different products released since then based on that family. It's really a similar look and feel to the i.MX 6 in terms of the hardware and the software, but it has upgraded performance and upgraded features. So our 8M family, we first launched into production in early 2018 with the i.MX 8M. We launched the i.MX 8M Mini earlier this year in February, and now we're launching the i.MX 8M Nano just 10 months since we launched the 8M Mini. So phenomenal record of bringing new products out to the market for your embedded application. Now the 8M family itself is built on the same CPU complex. We have a quad-core A53 and a Cortex-M coprocessor to give some offload, and I'll go into more details on that architecture shortly. But the 8M family is really your go-to product for general embedded capabilities. It has advanced computing with quad-core A53 processors, which is really becoming the new standard for embedded computing, and gives you the capability to scale up to provide future proofing as you want to add, for example, voice or machine learning to your products. You really want to settle in on a quad core. We have video encoded decode, so multimedia has always been a strength of i.MX, and there's no exception with the 8M family. We have integrated video capabilities, we have graphics, graphical hardware support through 3D and 2D GPUs. We have display and camera interfaces, we have high-speed I/O such as USB, PCIe, Ethernet. We've added more capabilities in terms of high-end audio support on our 8M family, and we have hardware scalability and in particular pin compatibility between the 8M Mini and the 8M Nano, which really helps you to create one platform that can scale different product capabilities and different product tiers. And then software scalability, because we provide a unified BSP release for Linux and Android across the entire 8M family. And we have industrial and consumer offerings. So the 8M family is a general embedded part. We really consider it extending across multiple applications, and we've already seen that be proven with the designs that we have today and customers that are shipping products based on the 8M family. Now, the 8M Nano is our newest product. So let's go into that in a little bit more detail. Key features. So let's start on the left. I like to talk about it being power efficient and scalable. So we have moved into 14 LPC FinFET. The 8M Mini and the 8M Nano are actually built in Austin using Samsung 14 LPC process. We do have a coherent, fully coherent core complex with a quad-core A53. And on the 8M Nano, each of those cores is running up to 1.5 gigahertz per core. We also have a bonus Cortex-M core. All of our 8M family has this bonus Cortex-M core. In the case of the 8M Nano, it's a Cortex-M7 running up to 750 megahertz. So it's really getting to be quite a powerful little coprocessor that can offer a lot of capabilities in terms of doing some low power management. It can be doing low power sensing, environmental sensing, taking in inputs, deciding when, what's worthy of waking up the big power hungry cores to act upon, and what can just stay in sort of a local low power state by running the code on the Cortex-M. There are other uses for it as well. We'll go into a couple of use cases a little bit later, but really very useful to have this second core available, and it can help significantly with some power management as well. And then, as I mentioned, the 8M Nano is pin compatible with the 8M Mini. We do have application notes that cover that, and we'll go into that later as well. The 8M Nano, in addition to the core computing complex, has a lot of capabilities in terms of multimedia. It has a 3D GPU. And what's new about the 3D GPU on the Nano is that it supports OpenGLES 3.1, Vulkan, and OpenCL 1.2. And why those are important is as you move towards newer versions of Android requiring Vulkan and OpenGLES 3.1, having those hardware capabilities is going to be necessary for you to drive the type of HMI you want and need if you're running Android. So it's really considering a future proofing for HMI applications. The OpenCL will allow you to run inferencing on the 3D engine, so you can get some efficiencies there without needing to run that model on the quad-core A53. So depending on the performance you're looking at, the GPU can be used for that purpose as well. We also have a MIPI display, which is for this type of application, driving up to a 1080p display is really where many of the display panels are from a cost standpoint. So MIPI DSi is an essential to have for the types of applications that the 8M Nano is selling into. We have a MIPI CSI camera input. So if you're wanting to do some vision applications, we have the MIPI CSI available, which again, moving away from parallel camera interfaces towards MIPI CSI as the industry trend is moving in that direction as well. We have a USB 2 high-speed interface. We have 10100 with Ethernet timestamping and then advanced audio support as well. The third key feature with the 8M Nano is what we're doing with our package and our system design. We do a cost-optimized package without impacting PCB manufacturing costs. We can get to a 6-layer board without microvias. We have support for multiple memory types. We're not just kind of forcing you to select one memory. We have multiple options available. We have some direct connection for PDM microphones if you're looking to add voice capabilities to your products. And we support Android and Linux BSPs directly from NXP. And then the other key feature, industrial and commitment to longevity programs. So we do have, as mentioned earlier, the commitment to ship industrial, -40 to 105, as well as the minimum 10-year longevity program for these products. Okay, so let's look inside the 8M Nano. Now that we know what its key features are, let's look into a little bit more detail. Okay, so here we have our block diagram of the 8M Nano. You can see this block diagram in our data sheets and on our website. You can get a lot more detailed information through that documentation. But this is what we put in there. Here is we break it up into the main CPU platform and then the low power security CPU. So we do have with the quad core A53, we have a 512 kilobyte L2 cache that's shared amongst all 4 cores across the entire cluster, and then a 32 kilobyte instruction and data cache. We do have different configurations of the Nano that can enable 1, 2, or 4 core A53s depending on the application, and they all use this same cache infrastructure. And then we have the Cortex M7, which has its own tightly coupled memory that can provide some performance efficiencies as you're running code on the Cortex M7. Now, the 2 cores do communicate through a resource domain controller, and that allows you to map peripherals to either the Cortex-A domain or the Cortex-M domain, depending on what needs access to what peripheral set. And it can be securely managed through that resource domain controller. You can also isolate certain regions of memory that are accessible only by the Cortex-A or only by the Cortex-M. There's a fairly sizable on-chip RAM with 512 kilobytes. It's largely used at boot time for memory initialization, for loading ARM trusted firmware, and all the boot level management. And then it can be used as a general scratchpad area once the operating system is up. It's largely available to the user to be able to make use of. We found this has been particularly effective for customers looking to enter some really low power modes where they can just use some local memory to store what they need instead of having to go off chip to the fairly power hungry DDR connection. So some good use cases there for how to optimize in on power. The 3D GPU is a Vivante GPU, the GC7000UL. It's a 2-shader GPU, and it has all the support for the APIs mentioned here. Very flexible, very lightweight, and really bringing out the capabilities that are needed in this class of product. If you want to drive a HMI, you really need a 3D GPU for it to be effective and what your customers expect from a HMI panel today. Connectivity on the right-hand side. So we have the MIPI camera 4-lane with the integrated PHY. We have the MIPI DSI 4-lane with the PHY as well. We have a pretty substantial set of audio interfaces driving more than 20 channels of audio if required for example, a multi-channel audio application. In addition to the audio interfaces that we have, we also have an asynchronous sample rate converter, which is new for the 8M family. It's new on the 8M Nano. And what it does is it provides the ability to do sample rate conversion in hardware without loading the ARM Cortex-A53 down, which could actually take 1 to 2 cores without having a hardware ASRC implemented. So really, providing great efficiencies for audio and extending the capabilities in that space. Low speed interfaces, we have I2C, SPIs, UARTs, all for connection to Bluetooth, to sensors, to PMIX, to other system peripherals. High speed interfaces, we have Gigabit Ethernet controller. And it supports the low power modes and IEEE 1588 timestamping. We also have USB 2.0 integrated controller and PHY. If more USB connections are required, you can use an external hub to achieve that. External memories. So we have support for multiple different memory types, DDR3L, DDR4, and LPDDR4. And we'll go through some examples of those and why you might choose one over the other in just a little bit. So stay tuned for that. We also have 3 SDIO interfaces, and where that becomes really important to have 3 dedicated interfaces is if you're adding Wi-Fi, it's likely to use SDIO. If you're booting from SD card, SDIO. If you're needing some expandable storage, SDIO. So we provide 3 so that we can cover all of those use cases. And here we have an example of how the SDIO might be used to connect a Wi-Fi chip, for example, from Marvell through a module. So it's really important to have that interface be available. In terms of boot media, we also have a couple of other options. We have MLC and SLC NAND. I know some of you are using SLC NAND for the robustness and the reliability. We do provide that support in the 8M Nano. And we also have dual channel quad SPI for lower density, more cost sensitive applications. Okay. And then on the left, we have security. So we have what you see in i.MX 6 today is largely what you see on the 8M Nano and the Mini and the original 8M. So we have eFuses for key storage. We have secure RAM. We have random number generators. We have trust zone, crypto accelerators, everything that you need to be able to lock down information and provide a secure boot for IoT device authentication and over-the-air firmware updates and ensuring that your product will only run the software that you want it to run. And then we have a variety of system control elements that are fairly standard, including temperature sensor, PWM timers, watchdogs, etc. So really packed with a lot of capabilities. We roll this all into a 14 by 14 millimeter package with a 0.5 millimeter pitch. We'll go into those details as well. And then we have the consumer and industrial products available today. Both products, both versions are in production. And they are on the 10-year longevity program minimum from NXP. If you go to our website, you'll see that they're already listed there on our longevity program. The other key thing to point out in this block diagram is that the boxes that are outlined with a red dotted line are differences to the 8M Mini. So this is a quick way for you to look at what some of those key differences are if you're looking to evaluate both products side by side. Now, where would one put the Nano? Where would you design it into? What are some of the target applications? Really, I've captured a very, very small number here. It is much more broader than this. But what I'd like to say is that the smart home, the smart connected home, as you know, is an incredibly growing area globally. The 8M Nano has the right capabilities for this smart connected home, and that includes smart appliances. So anything that needs, you know, if you're cooking, refrigerating, making coffee, talking to a light switch, talking to a speaker, running a thermostat, having a secure entry to your home or building, the 8M Nano is a great fit for any of those applications. If you're taking this to more of a commercial building, elevator control panels, building room management, again, thermostats and access control, a lot of those same smart home applications also extend into smart building as well. Industrial, so inventory management, barcode scanning, whether it's mobile or fixed, the power consumption that we have with the Nano can make it attractive for mobile applications as well, such as mobile scanners, factory automation and test equipment, even kind of heavily ruggedized requirements, because we do offer the industrial temperature and operating lifetime. We do get designed into those applications as well. Even remote monitoring. It could be on a security, it could be in a pipeline, it could be some remote location that's sending data back to a central hub. So a lot of possibilities there as well. Even in medical and the healthcare and fitness industry, really sort of, you know, this whole holistic health management, transfusions, you know, making sure you're taking medication when you need to, automatic pill dispensing, activity monitors, fitness equipment, anything to do with health management, anything that needs a display, even without a display, no display, connectivity processing, the price point for the Nano and the capabilities that it has it's an excellent choice for that type of application. And I know some of you out there are building audio. We've really started to create a lot of enablement and capabilities for audio, whether it's a network speaker, it could be portable, could be fixed, it could be a sound bar, a public address system. We have the audio capabilities to meet the requirements for those applications as well. So an incredible range of products that we're enabling with the Nano, and would love to hear from you on what you're building or intend to build with the Nano, because it's an exciting part. And one of the things I get the most joy out of in my day-to-day working life is hearing about what you're doing with products, because i.MX has such an impact on every person. It's really exciting to hear what we're doing with them. Okay, so with the 8M Nano, let's talk about some of the design challenges that you might have and how we're helping to address those with the product collateral and the part itself. So one thing I just wanted to cover first is memory selection. This is a topic near and dear to me because we see every day fluctuating memory prices. We see customers using all different types of memory for different reasons. So it's been really important to NXP to provide more than one memory option to you. as a customer who's designing in our product. We need to be supporting multiple ranges of densities of product, different performance levels, different power levels, and making sure that we enable you with the requirements, the reference designs, and the collateral to go with that. So with the 8M Nano, we support 3 memory types. We support DDR3L, DDR4, and LPDDR4. So when you're considering your memory choice, you may be looking at the density that's available. For example, DDR3L today has a much lower density range. So you might only need 512 megabit. And so that might be the sweet spot in terms of density and pricing for you. So you might elect to go with DDR3L. You might be looking at 8 gigabit or 1 gigabyte of DRAM, and DDR4 is very prevalent in that space right now. It has better performance than DDR3L. It has some better power management than DDR3L. So that may be a choice that you make to go with DDR4. If you're looking for absolute highest performance and or absolute lowest power, LPDDR4 would be the choice for you. And so that has an increasing range of densities becoming available. It's becoming very mainstream, being supported by many different memory vendors, all of whom which NXP does work with and regularly works on enablement with different suppliers of these different memory types. So the choice is yours, but we do provide options for you to try and get you the best solution for the product that you're building. And we do have reference designs for these different memory types, and I'll give you some updates on those shortly as well. So we really like to think that we're helping you to give you more flexibility in your design choice by giving multiple memory types as an option to you. Design challenge number 2, PCB Design and Layout. What we try to do, and we really strive to do this internally when we develop our package and our ball map and our EVK, is we do this process of co-design where our teams, all the hardware teams and the system engineering teams work together to build out the most smallest cost optimized package that we can without passing on an incredibly high manufacturing cost to our customers. So we're trying to create a really balanced approach of physically trying to make the parts small, because that translates to being able to support space constrained devices, but also saving you PCB cost as well. The smaller the XY area on a PCB, the less you pay. So there are efficiencies in cost to be realized from a small package as well. But we don't want to go and make it be a 0.4 millimeter pitch. So what we do is we decided 0.5 millimeter is the pitch we need. We create this depopulated array, and you can see this on the left-hand side of this chart. We've got the top view of the Nano and then the bottom view, which shows the ball map, and how we've created space to be able to escape the different signals. So you can design your board in 6 layers with high-speed DDR, mind you. You can use low-cost drills. No high-cost microvias are required here. So that translates to dollars saved. Standard trace and space escape routing. So it's not going to push you to very boutique PCB manufacturers. It's a standard methodology that is used everywhere. And then we've also optimized the power placement of the ball map to help you put the discrete components, for example, the decoupling capacitors, underneath the package to again create even more space savings for your product. And then the bottom view is an example layout, so you can see green is good. So it's a beautiful layout and something that we're extremely proud of. And we believe that it has great benefits to you for achieving high-speed DDR and achieving PCB cost goals that you might have. And we do provide all of our referenced schematics for our EVKs online, all of the design files. So you can go and use those as a starting point to really start implementing our best practices into your system. A third design challenge is designing for scalability. So how do you build a product that you don't know yet what features you might need in 2 or 3 years from now? So how do you build a product that can provide some future capabilities, and then you upgrade to it as you need it? So we do design for scalability with the 8M Mini, to enable you to design your hardware once and then scale it for multiple applications. And we actually followed the same approach with the 8M Mini and the 8M Nano. So what we're recommending to you, we absolutely implemented it ourselves. In our EVKs that we sell, we use the same baseboard for both the 8M Mini and the 8M Nano. It's a 2-board approach. We have a baseboard and a compute module. The only thing that's different between the two is the compute module, and the only thing different on the compute module is the DDR type. That is, and the slight change in the PMIC, and that is it. We were able to drop in our 8M Nano on our 8M Mini board, and we were able to bring that up very quickly. So it was certainly helped us to accelerate our design program as well by having this design for scalability approach. So you can see here we have the 8M Mini, and then the 8M Nano board is almost identical. And then even further scalability can be achieved through different SKUs that we have in the product portfolio. So we have quad core, dual core, single core. For the 8M Nano, we have versions with and without the GPU enabled. So if you're not doing, if you're doing a headless application, you can order a product version that does not have the GPU enabled for a slightly lower price. And with the 8M Mini, we have a similar approach with and without the video accelerator as well. We do have a design compatibility guide to tell you how to do this. As I mentioned, we created this guide as we went through the same process. So we've put all of our learnings into this guide for you, and you can download that from nxp.com as well. And here is the product lineup for the 8M Nano. So we have the Nano Quad, the Nano Dual, the Nano Solo, and then the Quad Lite, Dual Lite, and Solo Lite. The Lite version does not have the 3D GPU enabled, and then the Quad Dual Solo refers to the number of Cortex A53 cores that are included. All other connectivity is the same across the parts. All products are available today, so you can go to nxp.com or your distributor and place an order. We have all versions supported for both consumer and industrial products. So here are a couple of real-world application examples just to run through this. We have a smart connected appliance. So I mentioned earlier, this could be a refrigerator as shown here. It could be a coffee maker. It could be a washing machine, a dishwasher, fancy cooktop, anything of that nature. Driving a display. So in this particular example, we're running Android. So that's really important to have a quad core to be able to run an Android operating system. We have Android 9 running today. We'll have Android 10 coming in 2020. So we continue to upgrade our software as our new products come out. The 3D GPU is essential to run Android. Okay, so that is a key element that's used in this particular application example. We're using a MIPI DSi display. It's the most cost-effective display for the size. And this is a 1080p LCD. It could be 720p or 480, different resolutions that are available. And that does affect the amount of memory that you might put on your device. If you're running a smaller resolution display, you can get away with a lot lower memory density, maybe even 1 gigabyte. If you need more memory, you might be pushing up to 2 gigabytes. For this example, we've shown LPDDR4 or DDR4. Both options are a good choice. I think for the most power sensitivity, you would want LPDDR4 for the best power consumption. And then you'd have boot from eMMC. Some products, some connected appliances may require even more robust reliability, which might require SLC NAND. So that's a choice that you would make as the product designer. And then on the ARM Cortex-M7, so this could be used to run Class B safety libraries. We are working on this at NXP to deliver a reference for that. And that is important as you have these devices that start having a more rich user interface. You need to be able to ensure that the device itself is still going to do the job that it's meant to. And that's where these safety libraries come into play. And that is a great use of the Cortex-M7 core in this particular situation. Security is usually secure boot and then enabling secure over-the-air updates. You know, we have refrigerators for many, many years. We need to be able to update the software in a secure manner. And so our security infrastructure really allows for that. An example where you might have a camera coming in is a smart access control. This could be a panel outside of a building or your home that has a display and a camera, both using MIPI. You're taking the camera input to do face recognition. For example, mobile face nets could be running on the Cortex ARM A53 cores, which is a very robust, very performance efficient solution for edge processing to be able to do face recognition. So you could be running those on the Cortex A53 cores, as well as running, of course, Linux operating system in this case. Now you might not need as much memory for a smart access control, so you might choose to use DDR3L, maybe 1 GB, maybe 512 megabyte, but it gives you some options to scale down in that situation. And in this case, you could be using the ARM Cortex-M7 for doing some wake word detection. You could hook up a microphone and be able to do some simple voice detection. So keywords that would then wake up the rest of the system to do the face detection. And that helps with power management for this type of application. Okay, so how do we help you fast track your 8M Nano design? Okay, so we have an EVK that we really believe helps get you up and running fast. We have all the high-speed DDR routed, brought up, proven. We have design files available. We have LPDDR4 reference designs available on nxp.com as well. We have DDR3L designs coming in the second quarter of next year. We have a 6-layer board design, again, proven high-speed DDR, lower cost manufacturing. We have a PMIC that is BOM optimized and provides the best capabilities for our parts. They've been designed for the 8M Nano and the 8M Mini. So there's nothing extra there. It's completely optimized for these solutions. We have the pin compatibility. And then another really key element on our EVKs, which I think sets us apart from a lot of our competitors, is the fact that we have Wi-Fi Bluetooth enabled out of the box. So we do this through module partners. We're working very closely with both Murata and Azure Wave. And we use their modules on our compute cards. So you get our EVK out of the box, you have Wi-Fi Bluetooth enabled and delivered in our BSPs. So it's really exciting as we start bringing the Marvell Wi-Fi Bluetooth portfolio into our EVKs early next year. And we'll be able to start providing even more capabilities there. So the Nano Evaluation Kit is available for sale today. You can go to nxp.com, you can go to an e-tailer or your distribution partner and order an EVK from them. It comes with within the kit, you have the HDMI card, cable, you have USB Type-C power adapter, you've got the EVK itself. It comes with DDR4 memory and a Wi-Fi module, and then there are some optional add-on cards for displays and cameras that can be purchased separately. You'll note that these are the same accessory boards that work with the 8M and the 8M Mini. So if you already have one, you're great. You just need to get the Nano EVK. Today we have support for Linux 4.14 and for Android 9. Next year, in the early 2020, we'll be adding support for Android 10 and for Linux 5.4 as we move to the new long-term supported kernel for Linux. And then we'll have other partner solutions becoming available in that time frame as well. We're very pleased to have our early access embedded board solution partners with i.MX 8M Nano boards available today. So we have Boundary Devices, Varisight, Digi, Caro, Toradex, Congatec, and BCM, all incredibly tight partners of NXP. We've worked with them for many years. They have many solutions on all of our i.MX products. And the links in this presentation will take you directly to the 8M Nano solutions that they have ready and available today. So, you know, if you're looking to build some small quantity of prototypes, this list of partners is a great place to start to build out your product idea. So get started today. We have all our websites are active. Product documentation, data sheets, reference manuals, errata, design compatibility guides, ordering information is on i.MX 8M Nano. We have our i.MX 8M Nano EVK site, which has all the details of the design files, getting started guides, out of the box information, and really how to order the boards, etc. That's active and ready to go. We have our i.MX software site that has all the BSPs loaded to that support the 8M Nano. So our board does come imaged with Android, but if you need to go and get Linux or perhaps get a newer Android version, this would be your go-to place for that. We also have programming tools, and we have PinMux tools available as well. And then of course we have our community. The i.MX community, there's a folder for 8M Nano, and that has all of our engineering technical support. So if you have questions, please go there and post your questions. They could be technical questions or other, and they get addressed by our fantastic team that supports that community. Okay, so really excited that we've released this product in mass production. We like to think it gives you a world of smart possibilities, and really looking forward to working with you all and realizing your product ideas and building even more momentum around i.MX in the market. And now with that in mind, I'd love to open it up for questions.
All right, Amanda, there's some pretty good questions here. So
okay, wonderful.
That's great.
Take a quick sip.
Okay, so Stefan Walter asks, on page 12 of the slides, we already Ethernet, should it be 10, 100, 1000? So we have gigabit Ethernet, and I think you already answered that.
Yes, we do have gigabit Ethernet. So yes, that is confirmed.
Great.
Thank you.
Okay. Michael Kirk asks, is there a list of compatible cameras that will work with the CSI port for the 8M Nano? Are they supported by GPU acceleration?
Okay, so I think some of these, we do have some answers for those, and Monica, I'm trying to figure out how we can maybe follow up offline with some of these direct questions, if it might be a good question for the community, and then we can follow up there as well in terms of the specific cameras. I think if you're asking about GPU support, we don't use the GPU for the camera input. There are some partners that can do a soft ISP on a GPU, but most of our product designs would be with a smart sensor that already has the ISP integrated into the camera itself. But if you need a list of cameras, let's get this posted to the community so we can follow up there.
Great.
Good stuff.
Okay, Michael Kirk also asks, also, is there a list of compatible Wi-Fi, Bluetooth, RF modules that have driver support for 8M Nano?
Yeah, and we actually have a pretty good range of support. So so for example, I'll give you a couple of examples. Our 8M Mini, first 8M Mini EVK, we have a Murata module with a Qualcomm Wi-Fi solution. And we also have a Cypress Wi-Fi solution, and we'll be soon having Marvell NXP Wi-Fi solutions available. But we do generally work through module partners such as Murata and Azurewave. They're our most, Silex has also been a long-term partner of i.MX. They're generally the module partners that our customers go to, and they work with our development kits and our processes. So that could be a great place to start, is to go to a Murata or Azurewave they have, I know Murata in particular has a whole website on i.MX support. So that would be a good place to start.
Great. And this will be on the community site.
Yes.
We'll link them there. Okay.
Yeah, we'll link them there. Yeah.
Well, I will link to that in the chat as well.
Okay, wonderful. That's great.
Okay, so somebody asks, how many FPS for 720p video recording how many frames per second for 720p video recording can there be, I guess? Is there SDK available for video recording on bare metal?
So we would recommend for video recording to use the 8M Mini. It has a hardware video accelerator. And in our BSP, we have the capability to do the recording. We don't have a bare metal implementation, but we do have support for the camera, the MIPI CSI camera that I mentioned on the accessory board page. We have support for that camera doing video encoding on the 8M Mini. Soft encoding is possible on some of the other products, but I think if you're really looking for video encode, you want the performance and the power efficiency of a hardware accelerator, and so I would encourage you to go towards the 8M Mini in that case.
Anthony Burton asked, hello, is J1003 header Raspberry Pi compatible?
It's Raspberry Pi-like, so it's not fully compatible, but there are in our, we have an EVK design guide that's posted on the 8M Mini and the 8M Nano EVK site, and it gives you the details of the header and all the signals, so you can go and have a look at that. We do have a couple of boards that use that header from NXP. There's an NFC board that works with that header. There's also an 8 array board that we have that works with that header as well. And there could be other Raspberry Pi accessory boards that work with that header. It just depends on the board and how it matches that interface. But I would encourage you to look at the EVK user's guide to see the details of what's there and what isn't.
Okay, great. Zahar Marshall asked, did the 8M Nano go into production already?
Yes, it has. It is in production. Cool. And so if you go to, I know, for example, Digi and Mauser already have stock for these products. So you could go there and order parts today.
So Michael Kirk asks, what are the thermal cooling requirements for 8M Nano peak load, 4 cores, 1.5 gigahertz clock?
So that's a great question. We do have a power application note that we're just finalizing. It won't be posted yet, but I can follow up with you on the community and give you an early version. But there is no active cooling required. We do have a temperature sensor that can help to shift down as needed when higher temperature is detected and the cores are running really hot. Usually what we're finding is, between 2 and 3 watts total worst case power running all of the cores plus the GPU. I think if you're in a really tight space, a tight enclosure, you do need to do thermal modeling with any product. You should be doing that and implementing best design practices. It doesn't run excessively hot. It's very well balanced with power efficiency.
Okay, someone asked, does app Android development on i.MX boards, is it similar with mobile Android development?
App Android versus
app development, I guess.
That's a good question. I haven't developed any apps before, so I might need to take that as a follow-up. I mean, really, so what we provide is the Android BSP. So I think it's Android 9 right now. So whatever app development environment is used for Android 9 should be the same that can then be deployed onto our products. So I would think it would be the same, but if you need further detail than that, again, I would post to the community and we can follow up with an answer on that specific question.
Thanks. Okay, Siri asks, what the power management controllers are available for this MCU? Does the MCU require some solution for the dissipation of heat?
Okay, I'll just make one clarification. It's an MPU, not an MCU, just to clarify that. It's a microprocessor. There are a couple of PMIC options. We do have NXP PMIC available for this product. And there are some reference schematics available on nxp.com with LPDDR4, so you can go and check that out. And then there's also a Roam PMIC supported with this product as well. And so we have reference schematics for both.
Sally Dennis asks, where can I get the webinar? Oh, we'll post it. We'll send it to you afterwards.
Okay, great. Thank you.
Naveen Kumar asks, does the EVK have USB 3.0 or PCIe 2?
So there isn't PCIe on the Nano, but we reuse the same baseboard as the Mini. So the Mini has PCIe, the Nano does not have PCIe. The M.2 connector is still there for both. So that answers that question. Neither have USB 3 support. If you need USB 3, we have other products to address that. We do use USB 3 for power delivery. We use an NXP power chip on our EVKs that drives it through USB 3. Okay. The product supports USB 2 protocol. Yep.
Sally asks, does it support Z-Wave, Zigbee, etc.?
We don't have any native support for that right now. That would need to be more of a solution that we pull together and provide references for. Again, great community question. We can follow up there, but the EVK out of the box does not have that capability.
Okay. Pierre asks, what has driven the choice of MIPI DSI display interface versus LVDS, as industrial displays are not really available yet?
It's a good one. So MIPI DSI, we've found for the resolutions that we're targeting, it is the most cost-effective choice that we've seen and heard from our customers. Now, LVDS, we do have products with LVDS displays. The i.MX 6, several of them have LVDS display interfaces. We have other 8 products with LVDS. We have other products coming in the future with LVDS that is more of an industrial, larger resolution, or at least physically larger display. You can, if you really need an LVDS panel and you really want an 8M Mini or an 8M Nano or an 8M, there are converters available, MIPI to LVDS, that could be used to give you all the benefits of what we're building, but be able to drive the display that you want to drive. But you know, we would ideally like to support both, and as we move forward in the portfolio, we are adding LVDS capabilities to future products. But again, today there are converters available, and we felt that MIPI DSI is the best choice for a lot of the smart home, small display, physical size, and high resolution displays that are in the market today.
This is an interesting question. Guham asks, can you tell me a bit more about shared memory domains between M7 and A53 cores? Is there a possibility of communication between both cores while both are running?
Yes, so that is through the resource domain controller. And so we have that documented in our reference manual if you'd like to get more details on how that works. I believe in our MCU Espresso release for the M core, there are some examples of how to use the resource domain controller and how to send messages between both cores, the protocols that are required there. So I would encourage you to go and look at the SDK and the documentation, and then we can follow up on the community. But yes, absolutely, the cores can communicate to each other, and they can pre-allocate certain peripherals to each core.
Okay. Somebody asks, I think you sort of answered this, is 8M Nano compatible with Arduino Raspberry Pi sensors?
Oh, I think that question did come up. I would take a look at that EVK user guide. Now, just bear in mind though that if it does work, the sensor, there is no native software enablement for that board out of the box. So that would need to be a Arduino community enablement for that to happen. But if you want to see what physically could be supported, I would go and look at that EVK hardware guide and check the signal mapping for that header and see if it matches the Raspberry Pi accessory board that you'd like to use.
Okay, so Thomas asks, is it possible to boot U-boot from a SPI NOR flash connectors to ECSPI 1 interface?
Yeah, you can boot from SPI NOR. Yeah,
cool. Is HAV the same as i.MX 6 HAV?
HAV. What is the acronym stand?
HAB.
Oh, high assurance HAB. I'm sorry, high assurance boot. It's there is a newer version of it, but it's the same. It's the same flow, the same mechanism as i.MX 6. Yes.
Okay. Nitin asks, do we have any hardware accelerator for neural network processing or any software framework for utilizing GPU?
So we have previously announced our EIQ tools for being able to provide edge intelligence using the hardware that we have on our products. So there are some tools available and newer versions coming out as we speak. In terms of hardware ML acceleration, you know, of course, we're planning for that in future products. So look for more announcements next year. But right now we're using the Cortex A cores, the Cortex M for our i.MX crossover products, and then GPUs where we can. And I would look to the EIQ tools that we have, which is on nxp.com for more details on the tools and the capabilities.
Great. Okay, so we're at 9:01 and we have 9 more questions right now. Do you have time to keep answering them?
Absolutely.
Oh, great. Okay, cool. All right. So Naveen asks, can the cores be overclocked?
We do no. Our data sheet specifies the maximum clock rate that can be achieved. So if it's a consumer part, it's slightly higher. We do have an overdrive mode for a consumer product because the temperature is lower and the usage profile is a little bit different. For industrial, the core frequency drops a little bit because we give that 10-year operation and the 105 temperature support. But the data sheet specifies the maximum clock speed. So for the Nano, it's 1.5 for the consumer and 1.4 for industrial.
Mm.
Okay.
So Gutham asks, is it possible to use RDC from Linux environment? Is there support from NXP for dynamic management of the M7 core?
Well, these might be some questions we need to follow up.
Okay.
It's getting I think whatever answer I'm going to give is probably not going to be sufficient. I mean, I think I mentioned before, we have some examples for the interprocessor communication where you're running Linux on the Cortex A and you're running FreeRTOS on the Cortex M. So we have some application examples in the FreeRTOS SDK. So that could be, if you could start there, that might be able to show you what we can do. And then the reference manual gives the details of how they actually communicate. But that would be, from a software standpoint, I would look to the Linux BSP and the FreeRTOS SDK, and then we can follow up on the community if you have more questions about that.
All right. Someone asks, you mentioned Android support. We typically require 2 gigabytes of RAM for Android application, but I'm having difficulty finding X16 2 gigabyte LPDDR4.
Oh, good question. Okay, they are coming. I would talk to if you have a relationship with the memory vendors, I would talk to them about the roadmap that they have. We work closely with them, and they are building 2 gigabyte or 16 gigabit by 16 LPDDR4s. They probably won't be sampling, I believe, until the middle of next year, but we can work with you on that if you want to follow up through the community. But there are many memory vendors coming out with 2 gigabyte LPDDR4. You just won't necessarily see it today if you try and order it. So we can help work with you on that.
Cool. Naga asks, does the Nano support Dolby Atmos 3D immersion audio codecs? Are the audio codecs built in?
Dolby Atmos?
I guess so, yes.
We're fully, we actually are actually certified to run Dolby Atmos. We received the certification from Dolby for the 8M Mini and the 8M Nano. So we are certified to run Dolby Atmos. Depending on, we do have some ways to engage on the implementation. I think that would be, again, the community, and we can follow up with you directly. We have, NXP has a pro support team that can help you to implement that. So yeah, we can absolutely follow up and have more discussions on that enablement. But we are Dolby Atmos certified.
Oh, great.
Okay.
Gabriella asks, where is the storage used by Cortex M7?
The storage. So you always, the boot process is you always boot from the Cortex A, and then the DRAM is shared between the Cortex A and the Cortex M7.
Thomas asks, is it possible to boot from SPI NOR flash connected to EC SPI 1?
I think that was already asked.
Oh, yes, you're right. Yes. Have you partnered with any appliance manufacturers?
We are working with several. It's certainly a key application area for the 8M Nano.
Okay. Able to say who or?
Not at this time.
Gutham asks, what is the most low power mode configurable? Is there scaling core plexes? Can lowest power consumption be, is lowest power consumption reachable?
So the lowest power consumption would be in deep sleep mode, and you're looking at sort of low 10 milliwatt range for that particular mode. And then there are different steppings in between. There's idle mode with and without display, and then there's full operation mode. And even between those modes, there's a lot of different levels depending on your specific use case. But the lowest power mode, deep sleep mode, would be in that 10 milliwatt range.
Oh, great. Okay. So Gabrielle also asked, is the bootstrap process driven by Cortex M7 or Cortex A?
Is the what, sorry? The
bootstrap process?
Oh, through the Cortex A.
Okay.
Yeah.
How does the power consumption of 8M Nano compare to 8X relative comparison?
Oh, I don't have the details on the 8X, so we'd need to follow up on that one.
Okay, great. Okay, and that's actually the last question for now. So there's the community site. I posted it in the chat where you can ask your questions. We'll also send an email out with the link to the recording and the slides, Amanda's link to Amanda's slides. So I think, thank you so much for going over time and answering all these questions.
Thank you. I really appreciate everyone's time listening in and for all the great questions. They're really good ones. So, and if anyone out there wants to ask a question who hasn't yet, please hop on over to the community and we'll make sure we get those answered for you.
Great.
Thanks, everyone.
Thank you so much, Amanda. That was a fantastic presentation. And thank you for joining, everyone. See you next time, maybe. Yeah.
Absolutely. Bye.
Bye.
Okay.